So the, let's start with the problem of uh, a perpendicular wheel. We start with a axis, and this is a pole and a wheel it attached with it, and this wheel is rolling. So this is rolling around, and if this is moving the forward side, it would move in this side. So this angular velocity is taken to be omega. This is taken to be omega vector. So how do we arrange this problem? We take a cylindrical polar coordinates, which looks like this is the rho direction, this is the theta direction, and this is the k direction. So the total angular momentum, total angular velocity becomes omega z vector plus omega rho vector. Now this is a quantity which by which it moves at an instantaneous rate. This is a ever-changing quantity because theta is a function of time, but z is not. So if it's rolling like that, then the angular momentum of this whole system should be we can integrate it from r cross v dm, but we already know the answer to this query. It should be I as a I of along the axis of z, omega z, plus I on the axis of rho, omega in this direction. This quantity is this would be z cap, this would be rho cap. This quantity is given to be omega plus I rho cap is omega z. This quantity is given to be capital omega k cap. Now, what would be this quantity? This is the axis of z direction. The wheel is rolling like this. So, we have to apply uh, parallel axis theorem of ICM, and this length is L. So, IZ should be ICM to z direction plus LM ML square omega z cap plus I rho is just omega ICM rho direction omega rho cap. So it has three terms. These are the two terms, and this is the two terms. This two term comprises of LCM. So angular momentum about center of mass, also called spin angular momentum, is ICM z direction omega z cap plus ICM rho direction rho cap small omega. And the other quantity is the orbital angular momentum, which makes the center of mass move around it. So it's just r cross p, r cross total momentum, rcm cross total momentum, which is just uh, ml square omega, mr square omega is just for a single particle moving. This is just angular momentum moving. This is the else about this point, which is called the orbital of C. Now we come to the problem of a tilted wheel. If the wheel is tilted, the problem changes a bit in the respect of coordinate axes. The coordinate axis is not evident from this scenario, but we have to analyze the situation. Let we know this omega is given over here. We don't know the direction. We don't know the direction as of yet, but we don't know the unit vector because we don't haven't set the coordinate system yet. But knowing this direction, so the other angular velocity should be in the perpendicular direction to itself. So it should be in this direction. And now we can analyze if this is the direction of omega, then the center of mass should be moving towards this direction. So we have a situation where we want this direction with respect to every point, which comes as a spherical polar coordinates. If we imagine a sphere at the radius of r over here, with the radius equal to the length of this rod, then that sphere would have coordinates radially outward, which is r cap. A velocity vector would be theta cap, and this vector would just be the phi cap, where phi is this angle, and here phi is equal to a phi 0. So the phi cap would be a constant angle, but it would change with respect to time because the whole thing is rotating in theta. So theta is a function of time. Theta of the center of mass is a function of time. The radial distance of the center of mass is not a function of time. The phi of this angle of the center of mass is not a function of time. So we again analyze the same problem without solving any equations. We can analyze the angular momentum of this whole system should be I in the r direction omega r plus I in the phi direction omega phi. This comes about to be exactly right, and we need not make any changes. We can analyze this sort of the thing as this. We can ignore this omega, and we can analyze this situation where the axis is angled like this, moving like this, but the this is an instantaneous axis of rotation because the axis is ever changing. Axis is moving like this. When the uh, wheel comes in the opposite direction, the axis would be like this axis would go like this, but instantaneously it would move as if the axis is still and it is moving like this. So the situation is exactly similar. It would not change at all. It would be as if uh, this same quantity would come perpendicular direction cm, this same quantity. So perpendicular direction with respect to cm, omega r is just plus this ml square parallel axis theorem into omega r plus I phi is just this quantity parallel to the plane of the, yeah, wheel. So it would just be this quantity parallel cm omega. Omega r is written to be as just omega. Omega phi is given to be as omega vector. This two has both relations, so that it would not roll about. This is in the r cap direction. This is in the phi direction. So we can see this r cap and phi cap both are changing because of theta is changing. So theta cap is also changing. So we can see there are three terms: this term, this term, this term.